So our first warm-up question, okay? What did our slope in the lab represent? So who can raise their hand and tell me, what did your slope represent? So I want you to think about it for a second, because you basically had an X and a Y axis, right? And you had mass on one of them, and you had volume on the other one. So what is mass divided by volume that you learned about over the summer? Density, exactly. So number one, your answer is density. Okay? So I think one of the post-lab questions is asking for you to rearrange your y equals mx plus b thing. And what I'm asking for there is you should have recognized y is mass, m was your slope, okay, so that everybody's number will be different there. And then x was volume, right? Well, if I rearrange it to solve for slope, we now have mass over volume, which is density. And that's kind of what gave it away. Okay, so that was the big idea of the lab. If we didn't catch on to it, that's okay. We'll get it. All right. The next question says, what was intensive and extensive in the lab? So I'm going to have you guys answer that. So intensive things. Okay, so mass is going to be affected by how much you have. So I'm going to say that's incorrect. So if that's incorrect, you guys, what is the opposite? What's the other thing? Does volume change with amount as well? Yeah, so that's not, so both of those are what? Those guys are extensive, good. Okay, so we have mass and volume. So what were two other things that didn't change no matter what size you had? It was also one of your pre-lab questions, so. Huh? Density. Yes, density, exactly. So the fact that you guys were able to plot a bunch of data and get somewhat of a straight line, not from your data points, but a trend amongst them, tells you that that's an intensive property no matter what, okay? So no matter what, it has that kind of density, all right? What was another one? This is kind of a tricky one. What was something that didn't change no matter what size you had? Your clue is you had to look at it. What did you say? The object itself. So do the objects have a color? Yeah, did the color change just because it was tiny versus huge? No, color is an intensive property, and I want you guys to grasp that, okay? So intensive properties are really useful. They help us identify objects. So obviously if color is one of your observations, that'll help. Density is one of your observations, that'll help figure out who you got, okay? So some of you guys, when you're looking at your data table, maybe your slope came out close to copper, but you were like, our metal was not copper because it was silver, right? Then you could kind of deduce it down to going on the one that was 7.9, which I don't remember what it was, okay? So very important, intensive and extensive properties, okay? All right, and the last question said, what is precision? So in terms of bullseye, what was accuracy? In the same spot? Okay, so, but accuracy was specific to what part of the bullseye, you guys? The very middle, right? So accuracy was hitting the bullseye right on. Precision was what? What did it look like? Same area, right? It didn't have to be on the bullseye. So do you guys agree that we can define precision with this word? Consistency? Yes. Yeah, right? It's consistent data. It stays where it needs to kind of be. Might not be totally what it was supposed to be, but you are being a good scientist and you are collecting good data because it's consistent, okay? That's what precision is. So you will be asked that on the quiz tomorrow. Make sure you know the difference between accuracy and precision. Most likely I'm giving you some data. You got to tell me which one is which. No, actually, quiz, it'll be bullseye. Test, it'll be data. Okay? So that helps you. Study your bullseyes. All right. And then finally, this last little question was practicing your average atomic mass again. So the work for this one, what's the first step when you're calculating average atomic mass? Decimal to the left on the percent. So we had 0.9976 times the mass number of 16. Then you had 0.00037 times 17. And then you had 0.00175 times 18. Okay? And once you got those, you kind of threw them together. And you should have had 15.96 for this one, 0.006 for this, and 0.0316 for this guy. Total giving you 15.998. And that was your answer. Okay? So you do not lose this skill. I am asking this again. Okay? Are there any questions on how to do this? Possibly. Which? Okay, so we're going to take just a few notes over density. I am expecting that this is a review from your summer assignment. So it should not be new information. You should just be officially writing it. Okay, so I'm not going to spend a lot of time on it. If you're needing help, please come in and see me as soon as possible. So we are on the second page, the back of the second page. The back of the second page. Okay, so the front you took notes already. This is the back of it. Okay, all right. Excuse me. All right. So density. Density is mass per unit volume. Okay, mass per unit volume, which was evident in our graph, right? We had mass on one side, volume over here. So as volume got bigger, mass got bigger with the same element. However, okay, density is going to change with different stuff. You guys all had different densities in the end, right? So, so it's mass per unit volume. How much stuff is stuffed into a certain shape? That's the way I like to think of it. Your formula for this is going to be D equals M over V. Okay? The D stands for density. The M stands for mass, and the V stands for volume. Okay? All right. How do we find density? Huh? Right, volume, but yes, yep. All right, so we can either calculate it, right? Or what did you guys do in the lab? You guys did, what did you guys calculate after you put stuff on this little line thing? What was that? The slope, yeah. So you can graph it and find a slope. But density is something that you have to calculate. It's not something that you can just put on a balance and be like, voila, that's density, all right? So you have to calculate this. Mass. What's the only way you can get mass in a lab? Putting it on a scale, right? So you have to measure this. And then finally, volume. What are two ways you can do volume? What did you do in the lab? You took an object and you did what? What did you guys do in the lab, y'all? Come on, wake up. What? Okay, so we had a graduated cylinder. What did you fill in the graduated cylinder? Water. And then what did you do? You dropped the object into the water. What did the water do? It rose. That's called water displacement. Okay? Or if you want to put graduated cylinder because that makes more sense to you, that's fine. You have to be able to do both ways. That's why I'm stressing this right now. You got to be able to look at a question where I say it started at 47 milliliters and it went up to 49. What was the volume? What was the volume, you guys? If it starts at 47 goes to 49? 2. Okay, you have to be able to do that yourself. What's the other way you can get volume? You learned it in like geometry. No. You don't know density yet. You just want to know volume. What can I do with like a little cube? Yes, there we go. Length times width times height. That was one that I think we stressed big time in your summer assignment, and I do expect you to still have that skill, okay? And I think some of the practice problems have it, so if you had started those, cool. If not, you'll do it today. Okay, the only other thing I want you to write on this little section right here is density. We'll put the units on here, but mass, you're typically going to be using grams. Volume, you're going to use either centimeter cubed, which is usually when you calculate that, right? Because each one is centimeter. Or it'll be a milliliter, which is typically if you're using water displacement. But these two things, these guys right here, they are the same exact thing, so don't worry about any conversions. You just, whatever I give you in the problem, use that one, okay? All right, how many of us have ever seen this little triangle thing before? Right, yeah, okay. So a lot of teachers like to do that for you because it takes away the algebra. I don't give this to you. You are more than welcome to use it, but you have to learn how to draw your own tool, your own cheat sheet, and put it on your own test. So I will never give this to you, but I will show you how to use it, okay? So if you are solving for density, you're gonna cover up density, and you end up seeing that it is mass divided by volume, okay? If you're solving for volume, you cover up volume with your finger, and you see that it's mass divided by density. If you're solving for mass, cover it up with your finger, and you see that it's density times volume. So it is really useful, but y'all being pre-AP, I do expect you to either do the algebra or you make your own tool, okay? So as long as we're all clear on my expectation, cool? The quiz, I will probably put it up on the board tomorrow, okay? Just to help y'all out. All right. So units for density is just going to be combining what we already had up there. So grams per centimeter cubed or grams per milliliter. You will also see kilograms used and you'll see liters used, but we're gonna do that when I teach you metric system, okay? Which some of us already know metric system, awesome, piece of cake for you. Other people, we're gonna learn it. All right, are we all good so far? That's the math part. Now let's get some of the facts, okay? All right, so density. Density is it intensive or extensive? Intensive, good. I guess I should say an intensive property of a substance, and it can be used to identify objects. So just like knowing the color of something, you can use that to identify something. You can also use this, okay? Intensive properties, super useful. All right, put a big star next to this next bullet point. You need to memorize the density of water because I will give you a density column, tell you that water is somewhere in there, and you need to be able to tell me what these top guys are and what the bottom ones are. Density of water is 1, okay? 1 gram per milliliter or gram per centimeter cube, whatever you want to say, okay? Density of water is 1, and that's what I need you to remember, okay? Okay, an object will something, if the something is, will sink if the density is what? Greater than or less than the density of a fluid? What do you guys think? It has to be greater than, right? So most dense things are going to sink to the bottom. Least dense things will float to the top. That's the main idea of this little bullet point. So if it is greater than the density of fluid, it will float if it is less than. Which is why it's really, really important for you to know that water is 1, because then you can kind of decide where things will go in conjunction with water, okay? So if you have something that's less than it, it'll go on top. All right, so this just shows you examples are ice and water. We'll talk about that later. Basically in ice, everything spreads out in the solid version of water, and so therefore it's gonna be less dense all of a sudden because it just changed up its own density. All right. Down here it says the rectangle to the left represents a beaker. Draw how the substances would appear in the beaker. Water is at 1, we know that. A lead ball is at 11.4 and ethanol is 0.8. The way that you would see a question from me would probably be me not telling you that water is 1. Do you see where it'll help to know that water is 1? Just a little bit, okay? So let's go ahead and do this. So we know that we got 2 liquids, right? So let's go ahead and put a line down the middle right here. And then a lead ball is a solid, okay? Which liquid goes on top, water or ethanol? Ethanol, exactly. So you're gonna put ethanol here, okay? And then bottom you will put who? Water. And then what sunk all the way to the bottom? Exactly, the little lead ball down here at the bottom. Okay, so you need to be able to take words and make it into a picture, and me give you a picture and you figure out the words. Okay, so how many of us, is there anybody who has not seen a density column? And the density column is like when you have vegetable oil and you put water in the middle, and then you put like or alcohol on top, and then you can put like little objects like a Lego piece. And is there anybody who has not actually seen one of those? Because I'm going to pull it out for one of my other periods. Okay, I will make sure I have one for you. I will show you what that is. Okay, cool. So find the density of an object if the mass is 30 grams and the volume is 10 centimeter cubed. So this is just straight plug in, all right? I like to list out what I've got. Yes. Yes, absolutely. All right, so density, we can definitely do this one in our head. Density is a question mark. Mass is 30 grams. I like to always list it out so that they don't catch me on those questions where maybe they're not looking for density. All right, so this right here tells me I'm solving for density. So I have D equals M over V. I plug it all in. I get 30 divided by 10, and that is what? 3. So it is 3 grams per centimeter cubed. I'm going to put a nice little square around that. Okay? Are we all good with that?
Yes.
Like I said, it should feel more like a review. If you're struggling with it, please see me ASAP. Okay? Very, very important. Okay, so what I want you guys to do next is you're going to skip the next page. Then you should be on the density calculation page. So it should look like this. You guys have this. Oop. You guys have this one. How many of you guys actually started this with the sub? Awesome, perfect. Okay, so I'm gonna put the key up here. What I want you to do is I'm gonna give everybody about 3 minutes to give it a try. You do not need to do these 2 square parts. I know some of you guys started with it, and that's cool. So awesome if you figured it out. A little bit of that requires some conversions that I didn't teach you yet. So I'm okay with you starting on word problems, but I want you to go ahead and try 1 or 2 right now, okay? And then I'll put the key up so you guys can at least check your answers. So answers to the word problems, you can kind of check which ones you've done. I will have that key posted online, but I won't show the whole worked out key until the day before the test, like I did last time, okay? Okay, so moving on, we are on the page that looks like this, okay? Just a friendly reminder in your other packet, so in your Unit 1 packet, you took notes that looked like this. So you have sigfig notes. If you'd like to tear that page out and add it to this packet so it's all in one spot, by all means you can do that. Otherwise, this page actually has all the rules written for you again, just a little differently, okay? So we're gonna review with that first just to make sure we have not forgotten everything. All right, so all non-zero digits are always significant. So looking at this very first number, how many significant figures do you have? 5, exactly. Awesome. So all of those digits count. And you're going to see why that's important today. Okay, we're going to actually do some math. All right, the next one says captive zeros between non-zero digits are significant. Okay, what did we call those? We didn't call them sandwich, yeah. Okay, so this is the same thing as sandwich zeros. So looking at this number, we have non-zeros to non-zeros. So how many are significant? All 6. All 6. All those zeros are sandwiched in. It's like a little triple decker there. All right. Next thing we've got leading zeros are never significant. Okay, they're placeholders. So we can always write those numbers with scientific notation. So therefore, looking at this one, how many are actually significant? Only 3, exactly. None of these guys are actually counting, okay? All right, the next one says a bar over the 0. So this is one that we did not take notes over, and I will never test you over. But it's good to know, okay, is that if you do ever see a bar over one, that's telling you that's your last significant one. So what that does is it allows me to put a whole number like this and not have to follow my sig fig rules that you'll see today. All right, so it's kind of a cheating method. You do not have my permission to use it. Okay? I will give you answers that are always going to be roundable, and you don't have to use this, all right? But you'll see some people do this. So looking here, what that is showing you is that you actually only have 4. That last 0 is not counting, okay? Don't worry about it if that just went right over your head. I don't care. You don't have to know that one. Last one says trailing zeros are significant only if there's a decimal. So looking here, the first number has how many? The first number, 109000. Do any of those trailing zeros count? Nope. So how many are there?
3.
There's only 3 on the top one, okay? The bottom one, does this 0 count? The trailing one?
Yes.
Yeah, why? Because there's a decimal, right? The leading ones still don't count though. So you have 4 in the bottom one, okay? And then don't worry about exact numbers until we have done our stuff today. So that will come later. All right, so just a quick review. Just shout them out when you've got it, okay? Number 7. How many digits are there? 3, I agree. Good job. How about number 10?
3.
This is why we're doing this. All right, there are 3. Okay, 0.200. Both those zeros count because there's a decimal. All right, number 19. This one over here.
Does that count as a sandwich?
Does it count as a sandwich?
Yes.
Yeah, absolutely. So how many are there? 5. Good. Let's do one more. I'll feel better. How about number 16? 4. Good. All right. I feel good. So what you're going to do is you're going to turn over the page and you have a blank page. Mine has writing. Turn yours over. You now have a blank page. We're going to take some notes. We will be running very close to the bell. I'll try to, let me give myself a timer so I'll give you guys enough time to pack up. And basically, just like I told second period, whatever doesn't get covered, okay, it's not going to be, so this next step is the sig fig math. It's not going to be on your quiz tomorrow, but I will offer it as a bonus. So if you would like to go home and watch the rest of the lecture to write your notes in, that's fine. I'll count it as bonus, okay? Tomorrow with the sub, I will most likely have you watch the rest of it so you can finish it, and then you'll have practice stuff tomorrow, okay? Okay. All right. But if you want the bonus points, then make sure you watch it before the quiz, which is at the beginning of the period. Okay? Okay, cool. Awesome. So you guys have a blank page. At the very top, we're going to go ahead and title this Sig Fig Math. Just a reminder, SF stands for Sig Fig. Okay? So Sig Fig Math. Okay? All right. Sig Fig Math does use okay. Sig Fig Math uses your order of operations. Who remembers your guys' little PEMDAS? Yeah, exactly. All right, so we're going to write that off on the side just as a nice little friendly reminder that you do have to follow your order of operations. If you don't know what that is, it stands for parentheses, exponents, multiplication, division, addition, subtraction. So what this tells you is this is the order that you should be doing a very complicated problem, okay? Always start with parentheses, always end with your addition and subtraction. So I will just tell you right off the bat, when teachers are trying to test you over sig figs, we always put one complicated one to make sure you do each step. Probably for the rest of the year after that, I don't care if you do it in each step. I just want you to match it up to whatever I give you in the problem, okay? But for this first test, I want to see that you can do it. Okay? All right. The next most important thing, because this is an overlying idea for both types, okay? You are going to write, you are only as precise and I actually say accurate as well. Accurate as your least precise or accurate device. Okay? So if you have ever heard the little saying, you're only as strong as your weakest link, that's the idea. Okay? And that's why we do what we do. Okay? So now that you have that, that's the overlying idea. Now we can split the page down the middle, and we're going to write stuff on both sides. Okay? All right. On the left-hand side, we are going to talk about addition and subtraction. Okay? Those two types have their own rules. On the right-hand side, you're going to write down multiplication and division. They have their own rules. Okay? Okay. The big difference between these two is for addition and subtraction, the most important thing you've got to do is you got to count your decimal places. Okay? And if I'm ever giving you a reminder, you'll see me put DP. Okay? Instead of SF, it's DP. So when I say decimal places, I'm talking about, do I go to the tenths? Do I go to the hundredths? Do I go to the thousandths? Okay? When you're doing multiplication and division, your most important thing to do is you must count your sigfigs. Okay? You must count your sigfigs, which is why we learned in the first place which one is significant, which one isn't. Okay? Okay. The next thing, both of these are going to sound really similar, okay? They have to do with after you've counted them, your answer should reflect the smallest of either one, okay? So what that means, this on your addition and subtraction, your answer should only have as many decimal places as your number with the least, or as the one with the least. Okay? And we're going to go ahead and write the other rule, and that way if you go home and choose to watch it, all you're going to be looking at are the examples, which you can also look up on your own. Okay? All right. So when you have done this, if you have something that's like 20 versus, or 20.0 versus 20.22, you can only go to one decimal place because the smallest amount of decimal places was 20.0, so it only had one. Okay? Okay. On multiplication and division, your answer should only have, so it's going to sound exactly the same, as many significant figures, okay? So that's the difference there, and that's where everybody gets it confused. Significant figures as the one with the least. Okay, so if you have a number like 20 with no decimal place, there's only one. If you have 2002, so you're multiplying them together, your answer can only have one significant figure. So you have to round a bunch like on those kinds of answers. And that's what I'm going to put in these examples. So that's what I recommend you look at home. You guys can start packing up. Okay, so a couple of examples that we've got here for our addition and subtraction is going to be, if I were to have something like 14.357 plus 2.0, okay, what would the answer be? Well, following our sig fig rules, okay, is that we have to first count our decimal places. So counting these up, this first one has 1, 2, 3. So I'm going to kind of have that in a little circle. This one right here only has 1. So therefore, our answer can only have one decimal place. So when I type this into the calculator, I actually get the number 16.357. Well, I know that I can only go to the first decimal place. So I'm going to put an underline there. I'm going to check the second, and that tells me that I'm going to have to round up. So actually, the answer that we'll write is 16.4. And that satisfies the sig fig rules. Another example for addition and subtraction, if we were to have 20 minus 11.1, okay, if you type that in your calculator, you get 8.9. Okay, but let's check our sig fig rules. So looking here, counting up the decimal places, there's none here. So this is 0, and this one has 1. Well, the smallest of the two is obviously going to be the 0, so we cannot have anything after the decimal place. So we're going to check that 1 spot, check this guy, which tells us we're going to round up. So the answer you would actually report is only 9. Okay, on the other side, we have the multiplication and division. If we were to now multiply these two numbers, so we're just going to stick with the same numbers that we've got. So 14.357, and we're going to multiply that by 2.0. Okay, if you were to type that in the calculator, you would get something about 28.714. Well, we got to check our sig fig rules. We have to count our sig figs up. So in this first one, we have 1, 2, 3, 4, 5. So we have 5 total. And this one we have 2. Trailing zeros are counting for this one. And this one all non-zeros counted. So the one that limits us is going to be the 2 significant figures. So knowing that, I need to go 2 over. This is the one we're going to check. That guy tells us that we're going to go up. So now my answer is going to be reported as 29. And our final example, I'm going to go ahead and have 20. I'm going to divide it by 11.1. If you type that into your calculator, you actually get 1.8018 stuff. Okay, so looking here, we once again have to count our sig figs. This only has 1 significant figure. This one has 3. We have to use our 1 significant figure. So I'm going to go all the way from the left-hand side. This is our 1. We check it with the guy behind it, and that tells us that we have to round up to a 2. So that's going to be offered as bonus points tomorrow on the quiz, but it will be expected of you by the test on Thursday.